Hi everyone, this is Sunny Kumar from IIT BHU and welcome to our channel Code with Sunny. And today I am going to discuss the problem array operations of February circuits 2021. Okay, so let's jump directly into the problem statement without wasting our time. So in this problem we have been given an array A consisting of n elements and we have to find the maximum subarray sum after applying the following operation exactly once. Note that this is not that is we are not intended to apply the operation exactly one time, because after that you can see in the output format statement there is a statement we have to apply the operation no more than once. That is, we can leave the array as it is and find the maximal subarray sum, and this can be our answer. So I recommend my viewers to understand this. This is not exactly once, this is what at most once. Okay, so we can either apply the following operation a single time or we can leave it as it is. Okay, so what is the operation? We have to select any subarray and set all the elements in it to 0, and after setting all the elements in that subarray to 0, we have to find the maximal subarray sum after this operation has been done. Okay, so let's discuss the input format and output format also. First we have been given the t denoting the number of test cases. Now for each test case we have been first given and the value n denoting the size of the array, or you can say the number of elements in the array A, and we have been given in the next line the space separated integers denoting the elements of the array A. Okay, now what we have to print for each test case is we have to print a single line representing the maximal subarray sum after applying the given operation no more than once. So either we can leave the array as it is or we can apply the single operation one time and find the maximal subarray sum after applying that operation. Okay, so let's look over the constraints also. Test case is varying up to what 2 into 10 power 4 and goes up to what 1, 2, 3, 5 into 10 power 5. Our array values goes up to 10 power 9. Okay, so how we are going to do this problem and what would be our approach? Let's analyze that. Okay, now, so what is actually given in this question? We have been given an array of n elements. Perform the operation at most one time. That is, we can leave as it is or we can do the operation a single time. Okay. So what is the operation here? Choose a subarray and make all the elements of that subarray as 0. Okay, now what would be our goal? That is what we have to print, and what would be our approach, or you can say the main motive. So what we can do in this problem, we have to maximize the subarray sum after applying the operation above, or you can say, or leave it as it is. Okay, now what is the prerequisite that is required to solve this problem? Though, so main prerequisite that is required to solve this problem efficiently, or you can say it may be the hint or to solve this problem. That is, if you have solved this problem or if you have idea how to solve this problem, that is maximum subarray sum after deleting at most one element. Note that in this problem, as you can see, we have to find the maximal subarray sum after applying the following operation, where we have to select any subarray. That is, that array can have the size of what more than one. Okay, but if you have solved this problem like maximal subarray sum after deleting at most one element, that is a single element, then you can feel a little bit easier to solve this problem too. Okay, so let me discuss the examples and analyze how the output is coming and how what we can do to solve this problem. Okay, so let me hide this one and let me start with this. Suppose we have an array like this. So now what we are going to do is like let me do, or let me explain with this. Okay, now suppose here what we have to select a subarray, that I'm going to fill this subarray with 0, and then what we are going to find the maximal subarray sum. So what I am going to do is I am going to suppose I have selected this subarray. So okay, let me change the color of this. So I am going to select this subarray, and what I am going to do, I am going to fill this with 0, and remaining array will be as it is, and we have to find this what this maximal subarray sum, and we have to print this. Note that our naive approach would be what? We can traverse, or we can traverse through all the subarrays and put 0 it is, and now we have the new subarray and we can find the maximal subarray sum using Kadane's algorithm. But here we need to have the efficient approach to solve this problem to get the 100-point score. Okay, so let me give some examples. Suppose I am going to fill here with 0, and if we find the maximal subarray sum of this array, it would come what? It would come like 2, the single element. Okay, now, or you can say, let me have some extra, or you can say, if you can select these two indices and fill 0 here, then what would be the maximal subarray sum? We have maximal subarray sum of what? 1 0 0 2 would be our next array. So if you find the maximal subarray sum of this, it would come out to be 3. Okay, and what would be the case? Okay, let me, I have taken this example. Okay, now what I am going to do is, so let me write here, suppose I am going to have a subarray like this one. Okay, let me pick up this subarray. Okay, I am going to fill it with 0. So what would be our next, or you can say modified array? We have an array like this. So if you are going to find the maximum subarray sum of this array using Kadane's algorithm, it would come out to be what? The whole array, that is our answer would be 6. So how we are going to solve this problem using the most efficient way? So let us discuss. Suppose I have already said we need to have the prerequisite knowledge of maximum deleting at most one element. So suppose I have to delete at most one element, okay. So if I am not going to delete any of the element, I am going to find the maximum subarray sum of the whole complete using Kadane's algorithm. Let me denote it with K, or we are going to delete at a single element, that is, suppose I am going to delete this element, or you can say filling it with 0 is equivalent to what? Deleting that element. So I am going to delete this element. If I am going to delete this element, I have to find the maximum subarray sum of this array. So what is the maximum subarray sum of this array? It would come out to be what? You can say 6 5. So let me write here 5. And what would be the maximal subarray sum of this entire array? As I've already told, it would be come like what? Can you guess? Or you can, I am going to write. So it would come like what? 415, or you can say 426 plus what? 6 plus 7 minus what? 15. It would come out to be what? 5. Okay, this is the maximum subarray sum of this one. Or we can say, if we are going to delete this one, or we are going to delete this one, or we are going to delete this one, or we are going to delete this one. So how can we find the maximum subarray sum in O of n time? If we are going to delete a single element, you note that we have two arrays, one to the right and one to the left. So how we are going to find this maximal subarray sum after deleting a single element? We can find this maximum subarray sum after deleting at most one element in O of n time, if you look at these arrays carefully. So what about, I am going to find, I am going to maintain two arrays, that is forward, let me write forward, okay, and I have another array backward, let me write, okay. First, I think our viewers must understand how we are going to approach this problem. So I am going to maintain these two arrays, forward array and backward array. If forward array, what is forward array doing here? Note that forward array is going to denote, let me write, here we have forward array current maximum subarray sum after starting from the ith index, okay. Note that forward array is going to denote the current maximum sum till ith index, okay. That is, if I am at index equal to 4, then I have what? Forward of I will denote the current maximum subarray sum starting from the beginning to the ith index, okay. And what we have a backward of I? Backward of I is going to denote the current maximum subarray sum starting from ith index, that is starting from this index. Let me say we are at 4, starting from this index up to that index. And forward of I would be what? Starting from beginning to the ith index, you can say like this. So if we are going to delete this 4, let's say, so what would be our answer if we delete this 4? Note that our answer would be forward of I, what? Forward of I, plus backward of I. If we are going to delete this 4, so our answer would be forward of I plus backward of I if we are going to delete this 4. And similarly, if we are going to delete this minus 1, then our answer would be what? Forward of I plus backward of I. And here I would be what? Index of minus 1. And how we are going to solve this forward of I and backward of I, or you can say pre-calculate this, I am going to tell you in my later of the what, in my further, that is I am going to tell you in 2-3 minutes. Okay. So our next approach, or you can say, would be we need to find the subarray. That is, we need to delete a subarray. Deleting is equivalent to filling it with 0. So what we are going to find? We are going to find we are going to deleting a subarray. So what would be our efficient way to calculate the maximal subarray sum after deleting a subarray? Note that this can be efficiently calculated if we are going to take the prefix maximum. That is, I am going to write, okay, I am going to write here like calculate the prefix maximum, or you can say suffix maximum. If I am going to work with forward of I am going to calculate this prefix maximum. If I am going to work with backward of I am going to calculate with what? Suffix maximum. Okay. So if I am going to work with forward of I am going to calculate the prefix maximum. If I am going to work with backward of I am going to calculate suffix maximum. So why I am going to calculate this prefix maximum and suffix maximum? So we can also understand that if I am going to calculate the, if let's suppose we are at, let me write here, okay, I am going to make another 1 4 minus 1 and 2. Okay, now we have another this array. Now if I am going to calculate here, I am, let me write here, if I am at here, you can see, then if I am going to calculate the prefix maximum, and note that we have a prefix maximum of what? 5, that would come at here. And if I have prefix maximum of 5 for index at minus 1, then I am going to delete this subarray. That is, I am going to delete this minus 1 only. That would give us the what? Maximum subarray sum after deleting a subarray. So I am going to work with prefix maximum or suffix maximum and calculate the answers correspondingly for every index I, and take the answers take the maximum of all the possible answers accordingly. So let us move our approach, how to we are going to solve this problem. So our approach would be what? Dynamic programming, because I am going to use the Kadane's algorithm to find the maximal subarray sum if we are not going to use any of the operations. And also I am going to find what? Forward of I and backward of I for what? The current maximum subarray sum starting from the beginning to the ith index for forward of I, and similarly for the ith index to the end of the index for backward of I. Okay, so if a removal condition is not applied, then we can solve it using Kadane's algorithm. So the number of operation would be 0 in this case. So this can be our answer. So we need to consider this also. Now what about think about when a single element has to be removed, then maximum subarray sum we have to find. Okay, that's what I have said. That is prerequisite maximum subarray sum after deleting at most one element. If we know this concept, we can easily solve this problem also. How can we solve this problem? Note that I have given a hint, or you can say as maintain a prefix maximum or the suffix maximum and find out the work upon every index and take the maximum of the answer of what? Our new prefix maximum array or suffix maximum array plus the forward of I or backward of I correspondingly. Now I am going to make two arrays to handle the increasing maximum sum, forward array as well as backward array. Okay. Now current maximum subarray sum starting to ith index will be denoted by forward array, and current maximum subarray sum from ith index to the end will be denoted by backward array. Note that for every index we have these two values pre-calculated. Now we are going to handle three cases efficiently when no subarray is chosen. Okay, so this would be the basically we are going to do with Kadane's algorithm. And when the entire subarray is chosen, then our answer will be what? 0, because everything is filled with 0. Now when subarray of length is positive and length less than n is chosen, so we are going to handle this with the what? Forward of I and backward of I. and with the help of prefix maximum or the suffix maximum. Now for the case 3, to handle efficiently using O of n in O of n time, what I am going to do, I am going to find the prefix maximum of the above formed forward array. Note that you can also find the suffix maximum, it doesn't matter. But here I am going to use the prefix maximum. You can also use the suffix maximum. And let's say this is called by the array A. Now for every adjacent index of the array A and backward array, that is, you can say we have a new array A, then for every index I we have the what, prefix maximum from starting to the index I. Now I am going to add this, that is I am going to take the maximum of A of I minus 1 plus B backward of I for every what, for every adjacent index. That will give us the what, the maximum subarray sum after deleting one subarray, because if I'm going to take the prefix maximum, this will give the maximum value. So this will give the maximum value. So if the some maximum value is lying to some what, some earlier index, then this subarray will be deleted, that is from the index I to the what, to the find maximum index I that is earlier, that is less than you can say less than the current index. Okay, now finally I'm going to print the answer. Note that this will give us the maximum answer. Okay, so time complexity would be O of n. O of n for what, let me write, building forward array and backward array. Okay, and you can say also prefix maximum. Okay, now space complexity would be O of n. Okay, because we have two arrays of forward of I and backward of I. So let me go through the code and tell you how it is going to be implemented. Now we have a test cases T, and for each test case I have an n input array, you can see here. Okay, now I'm going to solve for each test case. So let's come to the solve function. So I'm going to maintain two arrays, forward as well as backward. Now forward is going to denote current maximum subarray sum starting from starting to the ith index, and backward is going to denote the current maximum subarray sum starting to the end index. Let's denote with fw and bw of size n. So basically I'm going to use the Kadane's algorithm, and I'm going to fill the current maximum up to the ith index in forward of I. Similarly I'm going to traverse to the back side, and similarly I'm going to fill bw of I. Okay, so let's start for filling forward of I. So I have initialized the base conditions for index 0, current maximum and maximum so far and forward. Okay, so I am going to start with I, and I am going to apply the Kadane's algorithm, that is current maximum equals maximum of the current element and current maximum plus the current element. Okay, so maximum so far will be what, current maximum of maximum so far and the current max. Note that forward of I will be what, current maximum, because we need to fill with what, current maximum subarray sum from starting to the ith index. So it will be what, forward of I equals current maximum. Now I'm going to for what I am going to build the prefix sum in the same array, that is in the same forward of I array. Okay, so it will be what, forward of I equals maximum of the previous and the current. Okay, now this will be for what, this will be what, building the backward array using the Kadane algorithm. You can see here I am going to highlight this. Now the steps are same, but I am going to traverse from the back side of the array. Now you can see I am going to handle three cases efficiently. Now what would be our answer if I am not going to delete any subarray? That would be maximum so far, that is you can see I am going to take with here from here. Okay, so if I am going to delete the entire array, our answer will be 0, so I am going to take maximum with 0. Now what I am going to do, I am going to choose any subarray. So if I am going to choose any subarray, I need to know the prefix sum or the suffix sum, you can say, and find for each element, that is adjacent index element, what, forward of I minus 1 plus backward of I. Why this forward of I minus 1? Because I have a prefix maximum that can have an index less than I, and if it has an index less than I, we need to delete the subarray from the what, index of this maximum up to my current index. Okay, and what would be the maximum value in that case? That is maximum subarray sum after deleting that subarray would be what, forward of I minus 1 plus backward of I. So I'm going to take maximum for every adjacent index. Now I'm going to what print my answer. So this would give the correct result. Let me submit this code and check out what would happen. Okay, yes, it is giving my full score. So if you have any doubts, do not forget to mention in the comment section of the video, and also the link to the code is mentioned in the description section of the video. And I will ask the viewers to like this video, share this video, and do subscribe to my YouTube channel for latest updates. Thank you for watching this video.